Well, welcome everyone. As you can see, there's a lot of people missing out, and you're the lucky ones that get to improve your life with JavaScript. So I'm Mark Volkmann. I'm from St. Louis, Missouri in the U.S., and I work at a company called Object Computing, and we do all kinds of things. We do consulting and training, and we work on open source software. Probably the most well-known open source software that we are kind of in charge of that you might have heard of is Grails. It's a framework for building web apps in Java. And I have some literature up at the front here that you can take at the end if you'd like information about the training we offer and our consulting services. There's some pens and stickers, so help yourselves to that. So I would say that there are three tools that have really improved my life as a JavaScript developer. I've been working primarily in JavaScript for the last 7 years. Before that, I was a Java developer for 15 years and many other languages before that. But the three tools that have really made a big difference for me are ESLint for checking my code for errors, Prettier for formatting my code. I highly recommend that. And then the third, of course, is Flow. And so we're going to get into that today. Before I do, I want to say a word about my slides. They're going to look different than all the other slides you've seen here. And you might think to yourself, what's the deal? Did I not get the message that today, when you make a presentation, you're supposed to have slides that have a picture and 5 words, and when you get the slides later, you can't decipher them, they're meaningless to you? My slides are not like that. My slides will help you learn how to use Flow, and if you give them to a coworker that didn't attend the talk, they'll be able to learn Flow from these slides. So that means that they're quite dense, but a lot of good information that you can get later. And that URL in the corner is real important. If you go to github.com, I'm M. Volkmann, and I have a repo called Flow Material. All of these slides are there, so you don't have to take a lot of notes while you're listening. So the talk is broken up into these parts. We're going to go through an introduction to Flow, then talk about how you specify types in Flow, the Flow server, which is the brains behind it, and then we'll walk through an example of setting up a project that uses Flow. There's so much I could say. I really need 2 hours to talk about this, and so I've included some bonus slides at the end for additional things that you might have questions on. And I also wrote an article about this recently, and there's a URL to that article there that you can get when you get a copy of the slides. Static versus dynamic. So types are specifying the conditions under which your code is going to run, things about the functions and the classes in your code. And in a static language, of course, you find out about the errors in your code when you compile it. In a dynamic language, you typically find out when you run the code, which isn't ideal. And so we have these type checking tools that you can use with dynamic languages. And in the world of JavaScript, there are two big ones. There's TypeScript and there is Flow. So why should you use types? Well, there are lots of reasons. One is that you want to find the errors before you run your code. That's more convenient. The other is that it gives good documentation about your code. When someone else is reading it, they know what you were expecting them to pass to this function, or they know what methods this class provides and the types that they expect. It increases your confidence if you need to do refactoring on the code. And boy, did I hit that big recently. I'm working on what has become a fairly big project, and I had to do a big refactoring. And I just think it would have been way more difficult if we hadn't been using Flow, because it found lots of errors that I was making as I attempted to do the refactoring. It removes the need for you to write code that checks types. Sometimes people do that when they're not using a tool like this. They'll write a function that the first thing it does is it might use type of and check what kind of parameter it received. And then you don't have to write unit tests that are all about testing types. You get to skip that part. Another reason is that there's probably a plugin for your editor or IDE that supports these tools, either TypeScript or Flow, and I highly recommend, if you're going to use one of these, that you take the time to set up your editor or IDE so that it can help you with this and show you the errors. With all that said, all these good reasons that you want to use types, there are also reasons that you shouldn't. And one of them is that it's going to take some time to get used to specifying the types in your code and mastering how to do that. It also is going to make your code more verbose, which is kind of distracting while you're trying to understand what is happening. And it will hamper you if you're trying to create a prototype or you're doing rapid development. It's going to slow you down. And initially, when you use a tool like this, you might feel like you're spending more time trying to satisfy the tool than you are getting some coding done. But after you use it for a while and you get a bit better at applying the types and you have to do some refactoring, the tables kind of turn and you start to see, oh, this is why I put in that effort. It's helping me a lot now. So you want to use types when your application is large or complex, or it's a critical app, you're working with a team of developers, you're expecting this code to have a long lifetime. If none of those apply to what you're doing, then maybe you shouldn't use types right now. And as we're going to see, one of the nice things about Flow is that it lets you gradually add types to your code. So you can take an existing app, add the use of Flow, and it won't do anything to you at first, and then you have to annotate your files to say, this is a file that I'd like you to check. And so we're going to see that syntax in just a bit. So this is a tool that comes from Facebook, and it catches lots of errors without you even adding types. Now, you do have to annotate the file and say, I want Flow to run on this, but you don't have to specify the types of function parameters, for example. And so it uses type inference, and it's really good at following the flow throughout your application to find that this variable got passed to this function, and it did some operation on that, and then it passed it to this function and to this function, and it traces all of that and finds errors without you even having to add any types. You can gradually add them. It has support for all the new ES6 and beyond features. And we get a lot of these things from Babel, so you might be using JavaScript features that aren't finalized yet, but it turns out that Flow can support a lot of those now, and so you can type check that newer code. And of course it has support for React and JSX since it comes from Facebook, but Flow is not just for use in React applications. I should say a bit about TypeScript. Of course, this is a competing tool from Microsoft, and it is a superset of the JavaScript language. And this is really a key difference. TypeScript is doing more than just giving you types. It's adding new language features. And for some people, that might seem like a good thing. And I think that it is, as long as those features end up getting standardized as part of the JavaScript language. But if they don't, if they're subtly different than what JavaScript lands on, then now you're coding in this thing that isn't quite JavaScript. For a lot of people, I think they want to stick with JavaScript. They're comfortable with the pace at which TC39 is adding new features, and they want to stay with JavaScript, and they just want to add types. And so that's what you get when you go with Flow instead of TypeScript. And I have a box up here to talk about Paul Graham's blub paradox. Some of you may have heard of this. This is from an article he wrote quite a while ago. I've got a link to it there. And the main idea that he was proposing here is that if you consider programming languages, there's a spectrum of features. There's very simple languages that are easy to learn and just do a few things. And then there's very complicated languages with lots of features. You might put Haskell up there in that category. And then there's everything in between. And it's your natural tendency to look at the language that you like and to say, there's all these things below me in the spectrum. I can't use those because they don't have all the features that are really important. And all those languages above me, why do they have all that stuff? It's just confusing and I don't need that. And that's the blub paradox, where you rationalize why you like your language. And that sort of applies to this comparison between Flow and TypeScript. A Flow person might say, all that extra stuff that TypeScript adds, I don't need that. But somebody that likes TypeScript would say, I can't use Flow because I need those extra features that Microsoft added. So that's an interesting point of comparison. So both of these, TypeScript and Flow, they give you JavaScript code. Actually, in the case of Flow, you're not changing it. You're always working in JavaScript. But TypeScript compiles down to JavaScript. And the way that you indicate that a file is using TypeScript is you change the file extension to .ts. And then it does two things for you. It does type checking, and it does the transpilation from the TypeScript code into JavaScript. That might seem like a good thing that it's doing both of them for you, but I actually think it's a bit of a downside. And that's because if you go with Flow and have it just do the type checking for you, then you can use Babel to do the transpiling. And why would you prefer that? Well, because lots of people write Babel plugins to do fancy things, including supporting features that are just at stage 1 in TC39. And if you want to use those, somebody has written a Babel plugin, and you can start playing with that now. And so I think that's an advantage of using Flow, that you can stick with using Babel and get to all those new things sooner. Another point of comparison is their support for specifying types for third-party libraries that you might want to use. A very common example is Lodash. So it's a utility library that a lot of JavaScript developers use, and you'd like it to be the case that if you're using TypeScript or Flow, that somebody has created type definitions for that so that you can check your use of that library and any other libraries. And so in the TypeScript world, they have this thing called definitely typed. And there's a website you can go to, and you can see that they have lots of definitions for third-party libraries. And the last time I checked, it was over 2,000 that they had specified there. The corresponding thing in the world of Flow is called flow typed, and it only had 570. And so that's a big difference and kind of a sad thing. I hope that it catches up eventually. Actually, it's made big progress to make it to 570. Fortunately, there is a tool that can read in a TypeScript type definition file and convert it to one that works with Flow. It's not foolproof, but at least it gets you part of the way there. But still, I would say this is a point in TypeScript's favor, that it has better support for type definitions of third-party libraries. Both of them, Flow and TypeScript, have good editor and IDE integration. And another good point here is that Flow wants to remain compatible with the TypeScript syntax. And so it turns out that if you start to use Flow and you decide 6 months later, hey, I think maybe I want to use TypeScript instead, it's not really that hard to switch over because their syntax is so similar. So if you want to install Flow, it's very easy. The trickiest thing is to remember that you shouldn't install Flow, you should install flow-bin. And you can install that so that it's globally available, and then you can ask what version of Flow you're using, and you can ask for help. This is not really the way you want to use it. This is more for experimenting. Really, you want to set it up to be a part of your project, and we'll show how to do that toward the end of my talk. So then when you want to use Flow, remember I said you have to annotate your files to let it know which ones should be type checked. And you have to do that by adding a comment at the top. //@flow is the simplest way. You can use the /* kind of comment as well. And any files that don't have that won't get type checked. It's easy to forget that. We forgot that in one of the files in our project and just discovered it last week. And of course, when we added that, some of those types were getting exported, and now all these things are getting checked that weren't getting checked before. And so we had like an hour's worth of work to do to fix things that we would have fixed earlier if we wouldn't have skipped that file. So keep that in mind. You got to mark all the files you want it to check. There is a way that you can tell Flow, just check this one file, don't check my whole project, and you use that check contents option on Flow. You might want to create an alias that does that for you. But really, you want to run it on all the files in your project, and we'll get to that later. When you're getting started, it might be useful for you to ask Flow to suggest what it thinks the type should be. And so you can run flow suggest and give it a path to a JavaScript file, and it will output its suggestions. And so if you look up here, you can see that my original code right there, rectangle area, computes the area of a rectangle. And then the output here tells me that width is probably a number, and height is probably a number, and this function probably returns a number. Okay, and then here where I use it, what kind of variable is area? And it says, I think that's a number. So this is a really simple case. It can do more complicated suggestions than that, but it's nice that it gives you a head start on that. Well, once all your type errors are gone, now you'd like to run your code. And as you might imagine, Node.js doesn't know about Flow, and your web browser doesn't know about Flow. So you've got to strip the types out of your code. And we're going to talk about a couple of ways to do that. But for right now, I want to focus on doing this just for code that I'm going to run with Node. And so what I want to do is install this thing called flow-remove-types. And that's going to install two things for me, flow-node and flow-remove-types. And so the first one, flow node, that's just a replacement for the node command. And before it tries to execute your code, it removes the types. So that's real easy. And then the second one is when you actually want to generate a new source file that has the types removed. And so you run flow remove types and give it the file you want to run on and direct the output into some new file. And if you do that without the -- pretty option, it's just replacing all the types with spaces. And so your code is still lined up the original way. It's just like whited out all the types. If you want to get rid of that space where the types were, you use -- pretty. And now with a new file, you can just run it with node. Either way, you've got to remember to annotate the files and tell it about the type checking. There's another option that I really don't like, and that is that you can put special comments around all the type annotations in your file with the /*: syntax for a single type, or to surround a type alias, which we'll talk about what those are in just a bit. You have to use a double colon. I think that's kind of an ugly approach. I'd rather just use standard flow annotations and then have some tool strip them out before I run the code. And then the project-based approach, we're going to get to that later. So let's look at some more examples here. This is an example where I've annotated a file, but I haven't added any types. I just have a simple function that's going to multiply two numbers for me. And I'm calling that in the line where I'm logging out the result, and I'm passing it a number and a string. And clearly this is not going to work because I can't multiply a number by a string. And Flow will catch that for me and say, hey, you gave me a string, but it has to be a number. The interesting thing here is that TypeScript will not detect this. That's because in TypeScript, you not only have to opt in by changing your file extension to .ts, but you have to add in the types. If you don't add the types, it's not going to detect that for you. But Flow is following the flow throughout your code, and it can see that you passed in a string, and it can see the operation you're trying to perform, and it'll catch those. So that's a big reason why I have a bit of a preference for Flow. Another part of Flow is catching uninitialized references. So here I have a function where I'm going to pass in a person object. And I'm expecting this person object to have a property called last name. And so I'm using ES6 destructuring right there to pull the last name property out. And then I'm going to check and see if there was a last name. And if there was, I'm going to return the first character of it. Otherwise, I'll return an empty string. But if I don't pass in a value for person, if that's undefined or null, or even if it's a number or a Boolean or a string, this is going to be a problem. And so below that, I create a person object. This one happens to have a last name, and then I call the function, and everything is good, and it outputs a V for me. But then I declare that variable P. I don't give it a value. It's undefined right now. I make the same call. That's going to give me an error. And Flow is going to say, hey, that's a possibly uninitialized value. So this is a really good thing. And when I first started using Flow, this was the number one kind of error it was catching for me. It wasn't the kind of thing where I passed a number, but it needed to be a string. It was that I didn't account for the possibility that something might be null or undefined. So I think this is a really good feature of Flow. So now let's jump over to talk about how you specify the types in a bit more detail. I've got a URL where you can get all the nitty-gritty details, and I'm going to give you an overview of that here. And so the kind of things where you want to do this, you want to specify the types of variables, properties and objects, parameters to functions, and their return types. And you do this by following a name of something with a colon and then its type description. Now, often TypeScript or Flow can infer the types for you. And this is an example where you might think, surely I don't need to say that it's a number because I'm assigning a 0, so it should know that, right? And that would be true if this was a const, because then it would know that it's always going to be 0, so it's always a number. But as it is with the let, Flow has to look at all the rest of my code because it's possible that somewhere else I might assign a string to that. And if I don't have the type annotation, then that's okay. And so the type of score then would be number or string. It can be either. So you want to do that if it's something that could change. There's also this concept of a maybe type. A maybe type says it's this type, but it also might be null or undefined. And you specify that just by putting a question mark in front of the type. Okay, and when you do that, it's going to make sure that any place you use that variable, in this case score, that you've accounted for the possibility that it might be null or undefined. And if you're just multiplying it by something and you didn't check first to see if it was null or undefined, that's going to be flagged as an error. TypeScript used to not have any support for this. Now it has this feature called strict null checks that you can turn on to get this same behavior, but it's not on by default. In Flow, this is on by default. Nothing can be null or undefined unless you put that question mark in there to say that that's allowed. So the basic types are what you might expect: Boolean, number, string, the wrapper classes for those, which almost nobody uses. Then there's null as a type. Void is what you say if it's going to allow undefined. Then you can use literal values. That's interesting. You're saying that it's not that the type is a string, it's the specific string. Or not that it's a number, it's 19 always. So you might think that that's not a useful thing, but I'll show you an example coming up later where I'm going to use a string literal, and that'll make more sense then. You can also take the lazy approach, saying that the type of this is any. It's kind of like turning off type checking for that thing, and generally you don't want to do that. Instead, you should prefer to use mixed. Mixed is like any. It means it could be anything, but I don't want to turn off type checking. I want you to require me to make some assertions about the type before I use it. And there's an example of that down at the bottom here. I have this function foo that takes parameter v, and its type is mixed. And I want to maybe multiply it by 2, or maybe get the length of it, but I can only multiply it by 2 if it's a number. And so I have to check for that, check the type. And I only want to return the length if it's a string. If it's anything else, I'll just return it. So if I don't do those if checks, I will get an error from Flow, because it requires me to do that, what they call type refinement, if the type is mixed. So here's a basic example. I have the function getChars. It takes 3 parameters. The first is a string, then I have a number and a Boolean. And what I want to do here is return some characters out of this string, either some characters from the beginning or characters from the end, based on the value of that Boolean from start. And so I have those types annotated. Notice that I did not specify the return type of this function. I could have said right at the end there, :string, because that is what it's returning, but I'm not required to specify the types. And then I have 3 calls to it. The first 2, they're just fine, but that last one, everything's wrong. 3 is not a string, false is not a number, foobar is not a Boolean, and so I get 3 Flow errors from that line. Flow understands all the built-in things, all the things from the JavaScript language, like array and console. It understands everything about the DOM. It knows about nodes and elements and the methods that you can call on those. It knows about the browser API, like geolocation and web workers and WebSockets. So it knows if you say that a variable is that type, what kind of methods you could call on it. It knows all about Node.js. So if you just require a Node module, it knows what you can do with that. It knows some things about React, like the special kind of event objects that you use with React, and more. And so you'll find all of this if you go to the GitHub repo and go down that branch. You can see these files. I have them listed there: core.js, dom.js, and so on. And it's very easy to read what it thinks the definitions of those types are. When you're taking the time to specify types in your code, it's highly likely that you're going to use it in more than one place. And so it's very convenient to give a name to that type so you don't have to keep repeating its definition. This is especially true for functions and for objects that are supposed to contain certain properties. So you give a name to that, and then later you refer to that type. Now, in the case of an object, when you specify the properties, you still can have additional properties added. You're just specifying kind of like the minimum requirements, or if these are present, they have to have these types. When you want to define one of these type aliases, you say type and you give it a name, and then there's some type definition here, and we'll see lots of examples of what goes there coming up. There's a strong convention that your type name should end in the word type, but it's just a convention. You don't have to do that. Another keyword in Flow you might want to look up later is interface. It's very similar to type, and I have a URL where you can read about the difference between those two. Most of the time, I think you'll use type instead of interface. here are examples of how you specify types for a function. We saw an example like this a couple of slides ago, so here's another one like that. I have this function monopoly, and I can specify whether I'm passing go, what I rolled on the dice, what piece I'm moving, and then I'm assuming that that result type is a type that I've defined somewhere else. So that's adding types to that function. Now what if I had multiple functions that had this same signature? Then I might want to define a type alias for that function signature. And so that's what I'm doing right here. And the only difference is that I've got that arrow right there instead of the colon. And so that's a difference when you're defining a type alias for a function signature. Remember that you add a question mark before something that is a type where it allows null or undefined. And that's what I'm doing in this last example here. This is a typical Node.js callback function where you first get an error if there was one, and then the result if there was one. And so that's why this is optional. The error might be null or undefined. Back up to this example, I want to say that z is an optional parameter. I'm getting a distance from a point to the origin, and it might be just a 2D thing, and I just have x and y values. But if it was 3D, then I want to specify the z parameter, and so that's optional. I put a question mark after the name of the parameter. Okay, I'm doing the same thing here for the result of the callback function. So pretty simple to add types to your function definitions. Next up, arrays. There are two ways that you can say something is an array. You can refer to the array class, and then after that, in angle brackets, you can specify what kind of elements go in that array. So Flow wants every element in your array to have the same type. You can also specify it by giving it the type first and then square brackets after it. And so these things are equivalent, an array of dates or a date array. Okay, and you can nest them, so I can have an array of arrays of numbers and specify that in two ways. And so here's an example of creating a type alias for that with a very crazy name that you would never pick. And then an example of using that, and there is an array of arrays of numbers. Another variant of an array is called a tuple, and this is just an array that has a fixed size where each of the elements don't have to be the same type, and I get to specify what those types are by their position. And so in this very simple example, I have a point type, and here I really want both of them to have the same type. Okay, but they don't have to. But in this case, I want them to be two numbers. And so it won't let me add more things to it. It always has to have a length of 2. And I can change values at a specific index, but I can't use all the array methods that would normally mutate an array. So tuple is a very specific kind of an array. There are 3 ways that you can specify objects. The simplest thing is to say, it's an object. So you haven't said anything about what properties it can have. You're just distinguishing it from other types like string or number or Boolean. You could also just use curly braces to say the same thing. But most often, you want to specify what properties are going inside it. Now, if I had written an ES6 class or defined a constructor in the kind of old JavaScript way, I would want to refer to that instead. And that's this third option, referring to a class or a constructor function name. But the second case is really common. I know that you're aware that in JavaScript, you often create object literals that don't belong to any class. And so in that case, you'll want to use this and specify what properties it can have and the types. And so here's an example where I have person type that has these 3 properties in it. And notice that spouse is optional. I don't have to specify that property. And if I do specify it, I can set it to null or undefined. Probably don't want both of those, but you could. All right, and then I want to create an instance of that, and so I'm creating this Tammy object, which is a person type, and it has to have the name property, and it has to have the birthday property. But notice I specified a height. Well, when you specify an object in this way, you're just giving it minimum requirements. You can always add additional properties to it. So then I specify another one down here, the mark type, and that one I specified the spouse. I didn't do that on Tammy, and so this appears that Mark is married, but somehow Tammy is not married. We're going to fix that on the next slide when we define a class for working with this. Okay? Now, what I said about specifying the minimum requirements and not being able to add more properties, if you don't like that, there is a way around it. You can use this extra bit of syntax to say, I need this to be an exact match, and there are 2 ways to say it. That's pretty ugly. I think I would do it that way with the vertical bars. Okay, and then I already mentioned just using a name of a class or a constructor function. Okay, so if I decide to go with a class, I could use ES6 syntax, and here I'm defining a person class, and it's kind of similar to that person object we saw on the previous slide. Here at the top of my class, this is unique to Flow. I'm specifying my properties and their types, but yet again, this doesn't mean I can't have more properties. It's just these are kind of a minimum set, and here I want to require a height. And notice spouse is a reference back to itself. Okay. Now, one thing that I cannot do here is I can't specify here that those properties are really required. I wish that there was a way to do that. So I'm really relying on the fact that I have this constructor and I'm setting those things, and there's no other way to create this, but I can't specify up here in the types that they're required. The absence of a question mark doesn't mean that in a class definition. Okay. So when I create an object, I do it like this, and then I can call this Mary method, and so Tammy, Mary, Mark, and you notice that I'm setting the relationship in both directions there. Okay, so with that class in hand, and I've created a couple of instances, I have this function where I can log out information about a person, and it's going to print out who they're married to, if they're married, and so I'm checking that here, and then I log out Mark, and that's good, but obviously, that's not going to work. I can't use a date object where it's requiring a person object. Okay? Let me get into some more interesting features. This is a feature that is present in Elm that I think is a really great feature. And when you read the Elm documentation, you'll see that as it's touting its own features, it at the same time points out how bad it is that these things are missing from JavaScript. And there are 2 things you'll notice about the Elm documentation. One is that it ignores the existence of ES6. It only compares to ES5. And the other is that it assumes that you're not going to use any kind of a type checker. So if you add Flow to JavaScript, you do get a lot of the benefits that you see in Elm. Certainly not all of them, but some of them. And this is one of those. So I can say that a primitive type means that it's a Boolean or a number or a string. And then if I say that something is a primitive type, I can assign any of those in. So it's not just one type, it can be any of these types. So 7's good, foo's good, true's good. Assigning an empty object, that's not good, because that's not one that I was allowing. Then this next example is one where I'm going to use a literal value for a type. And this is called a disjoint union. So I have an animal type, and I want to say that every animal has a name, plus it has a type property, but it's always set to animal. And then I have a mineral type, which is similar. It has a name, but its type property is set to mineral. And likewise for vegetable. And then I can create a type that combines them all. I have a thing type, which might be an animal or a mineral or a vegetable. Then if I want to create a dog object, I have to set the type to animal, and then I can put it in a variable that has a type of animal. That's all good. And a similar thing for mineral and a similar thing for vegetable. But notice that if I left off the type or I said something different, that would be an error. And so why do I want to do this? Well, one reason is that you can take advantage of this in a switch statement. And I could switch on the type of one of these things. And down here, I want to say that thing is a thing type, and I assigned in a dog, but I could also assign in mineral or a vegetable. And then if I use that in a switch statement and I switch on the type property, it would know what other properties are present here. Now, in my example, they all just have a name property. But suppose that animal had an extra property that mineral and vegetable didn't have. Then in my switch, if I switch on the type being animal, it would let me access that extra property. But if I was working with a vegetable and I tried to access that same one, it would know that that won't work because that doesn't have the extra property. So these disjoint unions are really useful for that level of checking. You can also use unions for a plain enumeration. So here I have an activity type, and you can either have it be swim, bike, or run. And then if I have a variable that's activity type, I can assign any of those 3 strings. But if I try to assign anything else, I'm going to get an error from that. So we finally have good support for enums as long as you're using Flow or TypeScript. Another interesting wrinkle on this is that you might want to say that the enumeration values you allow are whatever the keys are right now of some object. And so your application could start up, you could populate some JavaScript object, and then run code like this, which will look at that object and extract out what keys it has right now, and give you a type which is an enumeration of those. And then from that point on, you can only use keys of the object for a variable that has that type. Of course, after you define all these types, you're going to want to share them with other files. Your application isn't just one JavaScript file, and so you need to be able to export a type definition out of a file and then import it into another one. And so there's export type and import type. But as you might guess, just like working with normal JavaScript code, if you want to use ES6 imports and exports for, say, JavaScript functions, something has to bundle that together in order for the browser to use it, and most people use Webpack for that, and the same is true here. You need a module bundler if you want to take advantage of that. But for most web applications, you're probably already using a module bundler. So here's an example of that. In this file that is type alias export.js, I want to define some things and export them. And so first I have this thing called named type. A named type is just any object that has a name property, which is a string. It could have extra properties, but it at least has that. And then I have a function say hello. You have to pass it a named type. It doesn't return anything, so that's why I have void on the end of that definition. And then I'm just going to print out hello, comma, and then the name property out of that thing. So both of those get exported. Then in this other file, I want to import those 2 things, and so I'm using import type. There might be many things defined there, and I'm using this sort of destructuring-like syntax to pull out that one definition, and the same thing for pulling out the function. And now I can create something that's a named type that has a name and maybe other properties. And if I call say hello, that's going to work just fine. Here I'm creating a literal JavaScript object. I didn't say that it was a name type, but it does have a name property, and so that works just fine. But here I pass it just a string, and Flow is going to catch that because it's not a named type. Sometimes, not very often, you're trying to satisfy Flow and you just can't make it happy. And so when you hit a wall like that and you just want to move on, the easy way to do that is to add a special comment that says $flow fix me, and optionally you can describe what the issue is, and then it will ignore the next line. But I want to emphasize that it's very rare that you run into cases where you need to use this. But it's really useful when you're just learning Flow and you've got everything working except for this one thing and you just can't figure it out now and you don't have time to work on it. You can turn off Flow just briefly for that one case. All right, so now we want to talk about Flow Server. This is the brains behind everything that's happening here. It's analyzing everything about your code, tracing the flow, all the possible flows through your code, and keeping track of the types of variables and parameter types. It's keeping track of where everything is defined, and so there's a very good reason for that, and that is because the purpose of Flow is not just to do type checking, but also to help editors and IDEs do things like provide method name completion, or find all the references to this function, or in the future, maybe do refactorings for you because it knows so much about what's happening in your code. And so when you run the Flow server, it starts up a bunch of processes so that it can evaluate your code in parallel, and that's just for performance. On my machine, I noticed that it's starting up 10 Flow processes, but that really depends on how many cores you have in your machine, and you can control that. There's a configuration option that can change that if you need to, but the default has been working great for me. So by default, what Flow is going to do is examine all of the .js files that are underneath the directory that contains a file called .flowconfig. And we'll talk in a bit about how you create that file. Not any mystery here. You say flow init and it creates this file for you. And that's where you specify some options. In most cases, the defaults are just fine. So if you're in some subdirectory of your project, it's going to search upward until it finds the directory that contains .flowconfig. And once it's found that, now it searches down for every JS file and evaluates them. After it runs once, which might take 5 or 10 seconds if you've got a big project, it has now cataloged all this information about your application. And then from then on, it's watching your files. And if you change something, it will run flow on just that file. But if that file was imported in another one, it will see that and run flow on that one because that might have changed something. And it will see if you create new files and run flow on those. But the interesting thing about the flow server is that it doesn't output anything. It's checking all of this, and it may have found some errors, but it doesn't tell you about them. You have to ask it if it saw anything. And so we're going to see the command to do that in just a bit. And of course, your editor or IDE is going to do that for you and show you the errors. So to start up a server, you say flow start, and that starts it up in the background. And usually that's what you want. If you're using an editor or IDE plugin, it's going to do this for you, and so you don't have to worry about it. You could start it in the foreground if you want, and then if you want to ask the server if it found any errors, you type flow status or just flow, and that is not running a check, it's just asking the server, have you seen any problems? If you want, you can run flow check, which says, I don't care what you saw before. Could you do a fresh check of everything? That's not something that I do commonly. And then finally, you can stop the server if you need to by running flow stop. So now I want to walk through using this on a real project and all the steps that you need to go through. So this will be a good checklist for the first time that you use Flow. So the first thing you want to do is install a bunch of dependencies. And we'll get to all these steps on separate slides coming up. Then you want to put some NPM scripts in your package.json to automate some things for you. You probably want to set up ESLint. Hopefully you're using it already, and then you're just going to add some new rules to your ESLint configuration file to tell it to check your use of flow and make sure you're doing a good job with that. Then you want to set up Babel, because that is going to need to strip the flow types out of your code so that you can run it. Then you've got to create that .flowconfig file so that Flow knows where to stop when it's looking up the directory structure and then showering down and looking at all of your files. You probably want to set up flow typed so that you can install definitions for third-party libraries that you might be using. And then you want to set up your editor or IDE. So let's walk through how you do all of these things. So first step is all the dev dependencies. So step one, make sure you've got a package.json for your project. And if you don't, you just run npm init and it creates that for you. Then you want to do an npm install, and all of these are development dependencies. That's why I've got the -d. You could use yarn as well to install them. And then you just go down this list and set up all these things. A bunch of things related to Babel and its plugins, a couple of things related to ESLint and being able to check your use of Flow. Flow itself you want to install as part of your project. Optionally, you can install Flow Watch. This is good for when you aren't using an editor or IDE plugin, so that you could separately ask it to continually watch your files and output errors in a separate terminal window. But if you've got the editor plugin, you don't really have to have that. And then finally, npm run all isn't really related to this. It's just that it would be convenient if you could have an npm script that would do a bunch of things for you. You would like it to run ESLint and run Flow and then build your application with Babel, bundle it all together, and maybe run the code. And so npm run all lets you bundle all of that. Now you notice some of these things have a green check mark. These are the things that you're going to get for free if you're using Create React app, if you happen to be using React. But otherwise, you can just manually install all of those. These are some npm scripts that I recommend. So you want to have a script for Babel that's going to bundle up all of your code, get it ready to run. You want to be able to run Flow itself. Flow W is just a name I use for the variant that is doing the watch and continually watching my files and running Flow again if anything changes. Then I want to run ESLint, and I have the --quiet option, so it only tells me about errors. I want to be able to run my application. So I'm assuming here that this is a Node.js app. It's not a web app. If I were using a web app, Create React App would take care of that for me, or I could set it up myself. But here I want to run a Node app. And then finally my start script, which I'll run by saying npm start, does these 4 things. It lints all my code, it checks it with flow, it runs Babel to bundle everything up, and then runs my application. So we'll be relying on these scripts in our example coming up. Then I want to set up ESLint, and the bird in the corner means I'm going to go through this slide pretty quickly. I probably don't need to jump into detail, but you've got your ESLint configuration file, and it specifies a bunch of rules. And here's a list of rules that are very specific to using flow. And you could obviously pick different settings, but it's really great for making sure that you're doing it correctly. Then I went to set up Babel. And so here's a very stripped down version of the Babel configuration file. And the most important thing here is that I have this transform flow strip types. And so that's going to enable Babel to remove the type annotations so that I can actually run the code in a browser. I need to have this .flow config file. So all I have to do is run flow init to create it for me, and it will give me this file. It won't have this line right here. All these sections will be empty, and that's mostly okay. The main thing you'll probably want to add is that line that I have there to tell it, hey, don't bother running flow on the files in my node modules directory because that's third-party stuff, and they probably weren't using flow, so don't worry about that part. But I could tell it what files to check. By default, it does what you probably want. Libs is where it should look for type definitions for any third-party libraries. By default, it's going to look in a directory called flow typed. That's probably what you want to stick with. There's some options you can specify, but there are none that I commonly use. And then there's also an ignore section to say, I don't want to run on these files. And then you can pin yourself to a specific version of flow if you want to do that. So a big red box at the bottom. It's very important that you have a .flow config file because as I described earlier, if you run flow in some subdirectory of your project, it goes up and up and up looking for that. And what if it doesn't find it? It keeps going up and up and up, and eventually it hits your home directory, and it says, I can't go any further. I guess you wanted me to run flow on every JavaScript file on your hard drive. There's no way you wanted that, and I don't know why they have this behavior. They should say if they don't find a file, it does nothing. And so the impact of this is that your laptop all of a sudden sounds like an airplane taking off, because it's checking every file and your CPU usage has spiked like crazy and you've got to kill these flow processes. So in a Unixy kind of environment like a Mac, I type kill all flow. And that does it, but you could also run flow stop. This also happens if you've got a flow plugin for your editor and you're off in some directory where you weren't even using flow and you start up your editor. Now that plugin starts up flow, and it does the same thing. It hits your home directory, and your fan starts spinning. This is the biggest problem in flow, in my opinion, right now. So you'll know it's happened because you'll hear the fan come on. But the important thing here is create that file so this doesn't happen to you. Okay, let me say just a bit more about flow typed. So it's very easy to install, and then you run flow typed install, and what that does, it's not installing flow type, it's installing type definitions into your project. And what it's doing is it's looking at your package JSON to see what you depend on, and then it goes out to its site to see if definitions are there. And if they're there, it pulls them down and it puts it in a flow type directory that it creates for you. If it doesn't find them, it will create type definitions on the fly, and not good ones. Ones where the type of everything is any. They're just very weak definitions just to put something out there for you. So that's not what you want. If you see any of those, it might be worth your while to take the time to write the definitions yourself and submit them back so that this doesn't happen to other people in the future that want to use that same library. But to give you an example of the kind of things that are out there, here's a list of some commonly used libraries that do have flow-typed definitions. Then you want to set up your editor or IDE, the final step in my checklist. And so I have here list of some popular plugins for each of these that you might want to consider. And I tested this out in Atom and Visual Studio Code. Those are not editors that I use, but it was very easy for me to get it running. And I opened up code that had flow type annotations, and it right away was showing me errors. The integration is really nice. My editor is Vim, and so I have a bit more information about this, but I won't bore you with the details. Suffice it to say that if you do use Vim, this plugin Ale is just wonderful. It supports all kinds of syntax checks for many different languages, and Flow is just one of them that it supports for JavaScript. It automatically sees that you have them installed, and it just uses them and shows you the errors right inside Vim. Okay, so let's close up here by looking at a sample project that pulls all of this together. So this is a Node.js project that uses a very popular library, Lodash, and a very unpopular library, Liner, which is one that I wrote. Liner reads lines from a file and gives them back to you one at a time. You would think that would just be an easy thing in Node.js, but that's not the case. Node.js wants to treat everything as a stream, streaming across the new line characters. And so you need to do something special if you want to break it up at the new lines. And so that Liner module does that for me. So I'm going to use the start case function out of Lodash, which takes a string that has words in it, and it makes the first character in every word be uppercase. So when I'm ready to run this, I'm going to say npm start. We saw that script earlier. Remember, that's the one that uses npm run all, and it does lint and flow and Babel, and then it runs my code. So first I need to install my dependencies, and so we walked over all the tooling dependencies I needed earlier, but for this specific project, I need Liner and I need Lodash. And so I run that command to install those as not dev dependencies, but they're dependencies of my project. All right, and so here is our code. I'm going to start with the main bit of the code, and then we'll look at the utility that I wrote in just a bit. So I'm importing this thing called filer. That's on the next page in a file called filer.js. And that gives me a function, and I call that, and I pass to it a path to a file. And here is that file, okay? And it's going to invoke this callback function when it's done, and it will pass to me the number of lines that it processed. So I give it a function where it has a parameter that's a number, and it doesn't return anything, and it's just going to print out the line count. And here's that output right there. And filer itself is going to read these lines and then output the same lines, but notice that the first letter of every word is uppercase. So very basic thing that I'm doing here. So let's look at the code for filer. So here we've got filer.js, and I'm pulling in the Liner module, and I'm pulling in the Lodash string module. And then I have this one function that I'm exporting at the bottom, process file. And so here we have some flow annotations. Path is a string, and then the callback is a function with this signature. It expects a number, and it returns nothing. And then this function, process file, returns nothing. And so its type is void. So I set my count at 0. I create a Liner object. I tell it about the path. Then I have to register for some events. When I get a readable event, that means that there's some text for me to read. I've got some lines. And so as long as that remains true, I call liner.read, I get a line. I'll have to check to see, did I really get one? If I didn't, then I'm done with this event. But if I did, I'm going to call start case on it, convert the first characters to uppercase, and print it out and bump up my count by 1. And if this was a really long file, I may get several of these readable events. And when it's finished, I'll get an end event. And that's when I know it's time to invoke my callback function. And so I call the callback with the count. I might get an error. In that case, I'm printing out the error and then export that. And so going back to the previous slide, notice that the thing that I'm exporting is a function called process file. But over here on the import, I could call that anything I want. So I called it filer over there. So the main point here is that I threw in some flow type annotations, and I could say npm start, and it would run ESLint, run all the flow checks, and then run my code, including stripping out all the annotations. So my summary of all of this is that you need to think for yourself, does the time required to learn how to use this and to actually put the types into your code, is that justified? Are you going to get some benefit out of that? And in my experience, I've gotten a lot of benefit. As I said, initially, it was finding simple things like you didn't account for the fact that this variable might be null or undefined, and a bad thing might happen at runtime. But then later, when I had to do big refactorings, it was finding all kinds of issues that would have taken me much longer if I wasn't using Flow. So there are some reasons why I prefer Flow to TypeScript, but bottom line is I highly suggest that you use one of these. It's made a really big difference in my life as a JavaScript developer, along with ESLint and Prettier that I recommended earlier. And you should probably start simple. And that's a nice thing about Flow, is that it does let you start simple. You can just annotate some of the files and leave the rest alone until you're ready to add types to those. And over time, your confidence in being able to work on that code is going to increase. And so I have, I think, 5 minutes left. As I said, there are many more bonus slides here that you can check out later. But we've got time for questions, and maybe one of your questions will be addressed by one of these slides that we haven't seen yet. So who's got a question? The first one that's the hardest. Well, let me jump to one more thing to show you that is a difference between Flow and TypeScript. And that is this distinction between nominal and structural typing. So nominal typing is when you recognize a type just by its name. Structural typing is when you think a thing is that type because it just matches the other thing. Earlier we had an example where I had something called named type. And so it could be the case that anything that has a name property is good. It's kind of like duck typing that you've heard about. But in nominal typing, if your type is a class, you might say that just because I have this cat class and this car class, and maybe they both have a name, I don't want to be able to use a car everywhere where I use a cat. If I said it should be a cat, it should be a cat, or at least something in the inheritance hierarchy of that. But if you use nominal typing, that would allow you to use the car anywhere you use a cat, as long as they have the same properties and the same methods. It turns out that TypeScript uses, wait, I reversed that there. I was talking about structural typing. Nominal is by name. So TypeScript uses structural typing or duck typing. Flow uses structural typing when you specify object literals and their properties, but if you specify a class, then in that case it uses nominal typing. And that makes a difference. And so I walk through an example like that, and here I have a living thing class, and then I say plants and animals are living things, and dogs and cats are kinds of animals. And then I create this array of animals. It's empty now. And then I push into my array a dog and a cat and a plant. That's not good. I shouldn't be able to put a plant object into this array that is only supposed to hold animals. And Flow says that's an error. TypeScript says it's all good. And the reason it's good is that all 5 of these classes, they don't have any properties or any methods. So they all match. I think that's a little bit odd that it doesn't complain about that. And so that's another reason why I prefer Flow over TypeScript. All right. Well, I think that's all the time that I have. But if you have any questions about Flow or anything in the JavaScript world, please catch me sometime. Have lunch with me tomorrow. I'd be glad to talk with you about that. And you have all my contact information on that first slide. Feel free to shoot me an email. So thank you very much.